Hello everyone, good morning, afternoon, or evening, wherever you are in the world, and welcome to Ubuntu On Air. My name is Jose, and I'm an Ubuntu member broadcasting live from Peru. Welcome to this new session in Ubuntu On Air. This is the Quality Assurance Team Line-In Talks. This is the fourth session they're having. It's their first one on Ubuntu On Air. And today we're going to have two talks. The first one is about porting to Python 3, and the second talk is going to be the coverage report on Jenkins that they're doing right now. For the first talk, we're going to have Barry. Barry, you're going to have the slides here. Just go ahead.
Okay, thanks. Yeah, there's the slides. Okay, yeah, we can just skip ahead to the next one. It's just an intro slide. Yeah, there we go. Oops. Yeah, there we go. This is usually a talk I give in about a slot of an hour, and we don't have that much time, so it's going to be difficult to address all the technical issues. But I'm going to try to give some motivation for why you want to port to Python 3, and some resources and some general guidelines. And at the end, there'll be a set of links that you can go follow that will have tons and tons of information on how to port and how to address certain specific issues that you may run into. So let me start with, sort of why you are going to want to port to Python 3. And this includes both your libraries that you're developing and your applications. The main reason is that the Python 2 series is essentially at the end of its road. There's never going to be another Python 2. There's definitely not going to be a Python 2.8 release. PEP 404 is sort of the anti Python 2.8 release PEP. It describes exactly why we in the Python community have decided we are never going to release an official Python 2.8. So 2.7 is it. The good news is that we'll continue to do maintenance releases for a few more years, and once we've done the last maintenance release, a Python release will typically go into a security-only release. So you can really expect security-only releases for quite a while, and that's sort of good news. But at some point, the bugs will stop being fixed in 2.7. Now, the really critical thing is that most of the people that are actually core Python developers are really only working in Python 3. There's a few of us who still try to fix bugs in Python 2.7, and we always look at security issues, but all the new cool features and all the real momentum behind trying to make Python a better language is happening in the Python 3 release family. We are about to release Python 3.4 upstream, and you have that in Ubuntu. You have that in Trusty right now, and you actually have it in Debian as well. It's not quite. It's one of the release candidates, but as soon as the 3.4 final comes out, we'll make 3.4 available in Trusty. And in April, there is the 2014. We don't really call it US PyCon anymore, but it's going to be the North American PyCon. It's the big Python conference every year, and it's going to be in Montreal this year in April. And one of the things that we're going to be discussing is specifically Python 3.5 and how we can continue along the path of making it easy for people who are in a Python 2 world to forward port their code into Python 3. So that's going to be a focus of Python 3.5. And there's a language summit that we'll be having at the conference. All the many core developers will be there, and we'll be discussing, the future of Python there. Okay, let's go ahead and flip forward. There we go. Thanks. So let me touch briefly on what the Python 3 plans are for Ubuntu. Now, we've had a roadmap for many cycles, several years now. Python 3 is 5 years old, I think, at least. And we've known that this is going to be the future. So what we've been trying to do over many, many cycles, and sometimes we've had the opportunity to spend a lot of time on this, and other times we have had, just whatever cycles we've had sort of in reserve working on this. But really for 1404, the plan is we don't want any Python 2 on the touch images, and that's really a critical thing because touch images, the phones and whatnot, tablets are very space constrained. We already have Python 3 on touch. System Image is a Python 3 application, and we don't want to have multiple versions of the interpreter sitting on a mobile device. So one of the big ways to save space is to get rid of Python 2. We're not quite there, but we're getting there. One of the biggest things right now is Autopilot, and we're in the process of porting all the Autopilot infrastructure, the CI infrastructure, and all the individual tests and clicks and devs and apps over to Python 3, and that's still going on. We've also had a goal for several cycles to get rid of Python 3 on the default server and desktop images, and those are more difficult because we have some rather problematic stacks, and at some point we get to dependencies which have had a lot of difficulty porting, and we're trying to get there. Zapier is a big one that we're hoping to address, and there are a few others. But anyway, so we're trying to reduce the dependence on Python 2, and I think we're also working with Debian to get rid of Python 2 as a default version of Python. Ideally, we'd like to just demote Python 2 to Universe, just get rid of it. I think that will probably be a little difficult to do because of the way the Python build infrastructure works, but it's sort of our hope to be able to do that. And we'll never get rid of it from the archive, at least, not in my generation, maybe in one of your generations, but not mine. So those are our plans, and anything that people can do to help us get there would be really fantastic. So we can flip forward. Yep. Okay. Great. So I want to try to touch on some of the things that you can do now to help you get onto Python 3. Let's say you have a library, for example, that is Python 2 only at the moment, and you want to get to Python 3. Most libraries these days are what we're calling bilingual. They're both Python 2 and Python 3, and that's really useful for people who are already using your library on Python 2. You're not going to break them, but you're going to provide the opportunity for them to also use Python 3. For applications, most applications, it almost doesn't matter which version of Python you're using. What we're trying to do is port as many applications as we can to Python 3 and then just drop Python 2 as a compatible version. And there's a small number of applications which may need to still be bilingual, but hopefully we're reducing those. Now the biggest problem for porting is going to be your dependencies. If you have a very narrow dependency stack, or you have no or all your dependencies are also already Python 3, you're probably good to go. I mean, at least you can just focus on your own code, and you don't have to worry about your stack. So that's the big thing, and that's what we've been working on for many, many cycles, working with upstreams, working with Debian, so that when the upstream has a Python 3 version available, we have to do some packaging work to actually make that available to platform users. And okay, thanks. So import your dependencies. Switch your library deps to the Python 3 version. So if you have a package foo, let's say, like nose or mock, or well, mock's not a great example, but any Python 2 library, you're going to have a Python-foo library in Debian and Ubuntu, and if there's a Python 3 version available, it'll be Python 3 foo. So switch your dependencies. Set your depends and your build depends to Python 3 all, and that will pull in Python 3 and all the deb helpers that'll make your life a lot easier. In fact, if your package is using any deb helper other than Python 2, that's the dh with Python 2. If, for example, if you're using Python support, definitely switch over to dh Python 2. And when you add your Python 3 support, just include the -- with Python 3. And if it's both, then it can be with Python 2, Python 3. And that gives you some really nice deb helpers that make 90% of package builds like a 3-line build, like a 3-line rules file. There's a new thing that sort of augments or builds on top of the dh Python 2 and Python 3, and that's called PyBuild. And that really does a lot of things to make a bilingual library, for example, build usually just right out of the box with just a couple of lines in your Debian rules file. It does a lot of things for you. It'll automatically figure out your dependencies, your tests. It'll build for all available versions of Python. It'll run your tests against all the available versions of Python. Yeah, PyBuild is really great. As far as your own library code, let's say you're an upstream, the current recommendation, and I really subscribe to this, is to be bilingual from a single code base. It's really not that hard these days. There's tons and tons and tons of examples. Most of the current up-to-date recommendations suggest a single code base. For example, don't use 2 to 3. 2 to 3 comes with its own set of problems. Yeah, I'm running out of time. So, and my own personal opinion is Tox, which is a really nice test runner, is great if you want to support multiple versions, because with one command and one configuration file, you can run your tests against all supported versions. So, okay, let's flip forward. Okay, so really quickly, if you can't quite get to Python 3 yet, run Python 2.7 with the -3 flag, and that will cause a number of errors where your code is not yet compatible with 3, but without sort of going the extra mile. And what that extra mile usually entails is making sure that your Unicode and bytes story is straight. So you really need to have your model set. Python 2 let you be sloppy as far as what were bytes and what were strings, and in Python 3 you have to be really clear. And this can be a little bit painful for some applications and some libraries, but it really makes your life easier in the long run because you avoid tons and tons of Unicode errors if you can do that. As I mentioned, I personally recommend skipping 2 to 3. It has a lot of problems. And the 6 module is really great for having code that that works in both Python 2 and Python 3. A lot of times you don't need it because it's easy to just sort of manually work around language issues, but when you need it, 6 is a great module. And consult the porting guides. And if you flip forward one more, these are all the references that I recommend. And you can go to wikiubuntu.com /python/3, but that's really going to send you off to the python.org wiki. And that bilingual quick ref is really sort of the place to go to see lots of great techniques for specific coding issues that you might encounter, and it has lots and lots of other references to internet resources for solving problems. I highly recommend the Pragmatic Unicode video. That was from PyCon 2012, I think, and it will really give you a great idea of how to handle the bytes and Unicodes issue. And then finally,
well, Barry, I think you're out of time now. Thanks so much for giving us this introduction about porting to Python 3. It was quite interesting. So now we're gonna switch over to Alan Lysiash, who's gonna talk us about the coverage report on Jenkins that has been. This is some work that's been going on in the last couple of months, I think. So
that's true.
Let's just go over it. You will have your slides on in a second. So go ahead, Alan.
Okay, here to talk today about basic test coverage metrics. Um, and I think all of us kind of have had some experience with this, I hope. If you have submitted a merge proposal to Launchpad in the last little while, you may have noticed a link to Jenkins. Jenkins is our continuous integration service that the CI team has been ably running for us. And you may or may not have seen a graph for the number of tests that we've run for you, and then also a graph for code coverage that we've been able to detect based on these tests. Are my slides ready? Great. Go forward one. So what is it? So what we're doing under the covers when we're running your code, running your tests in Jenkins, we're compiling it with special flags that I'll talk about in a bit, running the tests, and then we're producing a report that shows what code is actuated by the tests. The results of this are, and again, I hope that we all have had some encounter with this to this point, and this is all review for everybody. But you get a few numbers, that is the line percentage and the branch percentage, and then you get a helpful markup of the source code. You go forward one, please. Or actually, here, can I screen share? I guess I'll screen share. So this is kind of what it looks like. So let's say we're interested in Mir. So here we have, I don't know, can people see when I'm gesturing? The number of tests we've run, the number of tests is getting pretty high, that's good. And then code coverage total for the project. So I'm going to dig into the code coverage report. Just click on that thing. I've noticed that on the public Jenkins that we're not, you can't dig all the way down to the source code, and I want to show that here. It's a problem that we'll have to address with the CI team. But just for the moment, let me pretend and do like a Julia Child thing. So for this small sector of the project, you can see that we have line coverage and conditionals coverage here. The lines are 100%. That's pretty good. And then maybe we need some help writing some tests that'll tease out these conditionals. And here you get a very helpful markup of the code itself. Let me make that a little bigger for everybody. Where you can see that evidently we just don't have a test that actually gets into this for loop, right? And so we're passing over it every time. Red means not actuated by the tests. So yeah, let me go back to my. So why do we do this? Let me switch back to my the slides, I guess. Yeah. So why do we do this? We found that this is sort of a cultural thing, that when developers get into this, if they're obsessed with quality, as they should be, the graphs enable them to track their progress. And furthermore, having that helpful display, it's achieving 100% coverage is kind of like finishing a crossword puzzle. And that sounds dismissive, like I'm talking like this is a game, but actually developers kind of like the game of hitting those lines that they may have missed, and using techniques like mocking and so on, enables them to do this. And the QA team is here to instruct in how to do this. So, and then for QA, why do we do this? It helps us to assess the quality of a project's test suite. Some projects have very few tests, some have a lot, like Mir. And further, we're responsible for so much code that having a coverage measurement enables us to see where where our effort is best spent. Forward one slide, please. Okay, now this is where it gets kind of technical. This may or may not be fun for us. And I guess I'm addressing specifically the C-based projects that we're hosting. C, C++, Savannah, and QML. Let me see here if I can open this. Maybe we'll go back to the screen share, please. So if you're familiar with doing dev builds, this snippet of Bash is deep in the bowels of our implementation of what we call pbuilder Jenkins. We can run pbuilds under Jenkins, and here's where we're actually using sed, I believe.
Sorry,
to
Alan.
Yes, go ahead.
You're not screen sharing at the moment, so if you please
hey, man.
enable.
1 second. There we go. Okay. Back to what I was saying. So here's a paste, and if you get the, please join me on this page if you can get the link from the notes there. Anyway, if you're familiar with doubling, this is relevant to you, or you can grok this, where we're actually adding these coverage flags. Sorry, I'm parsing this here. Right. And then, sorry, going forward in the slide here. Sorry about that. So having produced these this coverage artifact, it can then be parsed by something called gcover, which is just a Python project that makes the coverage artifact parsable by the Covertura plugin. And then it'll show up just as a ordinary Jenkins artifact. This coverage XML is what we're interested in. No need to really actually dig this up. Thank you. Okay. And then finally, it's just this Covertura will make the graphs for us. Forward 1 slide, please. How are we doing on time? Okay, so as a manager, you probably want this for your project. You may arrive at your Jenkins for the project and discover my project doesn't have coverage reporting. This is what you need. Your project needs a make check or make test target. You need to have a test, or else you won't see anything. And actually, the build will fail if no artifacts are found. And then finally, the CI team needs to enable coverage for you. And enabling this may be changing as we have a new build system coming. Formerly, this was just a matter of asking for some help from the CI team, and they would make the config change to C upstream to distro project. And I'll ask you to consult with them about how to do this. Forward 1 slide, please. Okay, so if you want to have real control of doing this on your own system, and you are a lead Axor and you care about quality and testing, consider adding a coverage target to your project. We have examples. This is faster than Jenkins. You don't have to wait for Jenkins to do the build. This is what you'll be doing if you're doing a TDD type process. We have examples for these make systems: AutoTools, CMake, QMake. This is pretty widely spread in our within Ubuntu now, and we're here to consult with you to help you do this. Forward 1 slide, please. And then I'm going to go without a net here and show you what this looks like if you're doing it on your desktop. It's going to look like this. I'm going to start Julia Child style, having already branched XPath select. And notably, XPath select already has a coverage target. So we're just going to do the build. Or I will have already done the build, and I'll show you what the LCOV artifacts look like. So if you could switch to my screen, please. Can everyone see my screen? Okay, so I've already made this build directory, and the build is already made, and we'll just look for the coverage artifacts quickly. CNO. So these 3 items are sort of like symbols that correspond to the .o files that are produced here also. So let's, the test. So corresponding to these three .o files. So if we then make check, oops, sorry, make test. Okay, sorry, my tests have already run, but then you'll find these .gcda files, and these are the artifacts that represent the arcs of code that have been touched or executed, actuated by the tests. So now, if I switch over to having a look at the LCOV output, or actually here, let me rehearse that for you. Use something called LCOV. Sorry, let's try again. So this is a long command line. Forgive me for not going through all these different options. But the idea here is to a further step to parse those artifacts. Okay, that's fine. You get some warnings. And then finally, let's use this Gen HTML tool to actually make a pretty web page out of this. Okay, and let's have a look at what it looks like. This is painful. Sorry. Okay, there we go. Almost there. Coverage report. So we'll see an index here. Now, because of the way that CMake builds its projects, all of this other stuff from user gets in there too. But just want to look at the code that's actually relevant to XPath Select. We're doing okay. Well, I don't know. This file has pretty good coverage. I'll just assume you can see this. Aha. So here's the line that we're not executing. So anyway, you can see how if you're in the process of writing tests, you come back to this HTML page and know what you need to fill in. Maybe go back to the slides. I have 2 minutes. So caveats. File coverage is important. If a file isn't mentioned in any tests, its line branches are counted, and this can result in distorted results. It's possible to game the report by just turning off LCOV. Don't do that. That means that we have to go in and fix it. And there are, using Vala, for example, all the code is auto-generated. Is it really relevant to have coverage? And so I'm offering a solution here that Mike McCracken has worked through. Finally, most importantly for the phone image, QML is declarative. It isn't instrumentable. And so Michael Zanetti has worked up something for Unity 8 that enables something similar. Last slide, future directions. So we'd like to make a dashboard that will give a higher level view. It takes a lot of clicking in Jenkins to actually get the info that you need. We need to unearth these reports because we actually have limited time to serve all the quality needs. Lastly, we've considered gatekeeping, or at least alerts, on significant dips in coverage when an merge proposal is introduced that has reduces the coverage significantly. What do we want to do? And then finally, I'd have some research ideas for ways that we can differentiate between good focused tests and not. Last slide. Thanks, everybody. And just find me on Freenode if you have questions. And of course, we're always hanging out in Ubuntu quality on Freenode.
Awesome. Thank you so much, Alan, for giving us this presentation. So if you have any questions about these two presentations we've just had, you can just go to #ubuntu-on-air. Barry and Alan will be in there for a couple of minutes, I assume, so they can just go ahead and answer all your questions. Make sure to subscribe to our YouTube channel, youtube.com/ubuntu-on-air, and follow us on Twitter at twitter.com/ubuntu-on-air. It's been a pleasure to be here again. Thanks again to our presentators, and see you this Tuesday on our regular John A. Bacon Q&A.
Super. Thanks, everybody.